morning everyone. Today we are here to discuss a case study about comparison between line-to-line fault and single line to ground fault. I would like to initiate the discussion by defining the scenarios. We are analyzing an unloaded generator which is subjected to two types of faults, mainly single line to ground and line-to-line faults. The unloaded condition means pre-fault currents are zero, terminal voltages are balanced, and the system we are analyzing is under subtraction reactance. However, three-phase faults are considered to be more severe in overall cases, but in unloaded generator, single line to ground fault is considered to be more severe if it is connected in single line to ground, and as there is three types of sequence impedance connected in series. And the expanding the SLG fault, imagine phase A short to ground, and here the current in which the voltage is load is connected, and fault current equal to IA, which is which is 0, and connected, and IB and IEC are connected in is 0. Then in turn, symmetrical components are connected in the three types, like positive impedance and negative impedance and 0 are connected in series in the fault point, and the fault current are calculated by 3 EA divided by sum of all positive and impedance, negative impedance and the neutral. In that highly depends on the grounding point. And my point is about line-to-line fault. And line-to-line fault happens when two phases touches each other. For example, phase B and phase C are without touching the ground. In this condition, the current in A phase is 0, so I is equal to 0, and current in B phase is equal and opposite to C phase, so I is equal to minus IC. And coming to line-to-line fault. So coming to line fault, there is no need of zero sequence network. Only the positive and negative sequence are involved, and the fault current is denoted as IRL is equal to root 3 EA by Z1 plus Z2. Here Z1 and Z2 are low here, so the impedance is low here. There is no ground path. The fault current is usually less than the single line to ground fault.
My point of this comparison of SLG and LL. In single line to ground fault connect positive sequence impedance and negative sequence impedance and zero sequence impedance in series. Then sum of positive sequence impedance and negative sequence impedance and zero sequence impedance. Then three types of neutral sequence impedance are in sum. Then line-to-line fault connections, positive sequence impedance and negative sequence impedance in parallel. Then sum of positive sequence impedance and negative sequence impedance is sum. In the line-to-line fault, zero sequence impedance as in a fault current. Then however, the most of the generator are zero sequence impedance in fault. Then single line ground fault connected typically produce a high fault current compared to the line to line fault. Additionally, the single line fault current causes the other two cases like health phase voltage to rise the line to line current source voltage, causes of significant isolation stress.
My point is the role of grounding and role of grounding. The crucial part, most of the SLGs or SLG means single line grounding. Most of the single line groundings are in the crucial part of the grounding because SLN is equal to 0. But high impedance of the grounding can be calculated impedance value. But most of the crucial factors are affected the extra impedance also. But in the impedance value, the high impedance can be above the crucial factors of the SLG to grounding.
To summarize, both single line to ground fault and line to line fault are asymmetrical fault that produce unbalanced condition. The single line to ground fault is the most common fault that occur more than 70% of the time. They are very severe due to series connection of positive, negative, and zero sequence impedances. The line-to-line fault is the rare factor that occurs only less than 3% of the time, and it is less severe due to lack of zero sequence relay. The generator differential production should be able to act very fast to single line to ground fault, while the backup production should be able to withstand high insulation.
Okay. So from this case study, the comparison of single line to ground fault and line to line fault. So normally in a power system, there are majorly two types of fault. One is called symmetrical fault, another one is unsymmetrical fault. So the symmetrical fault is nothing but all three phases are getting faulted. That is called three-phase fault. Is called symmetrical fault. So it is very rare. It is less than 8% only. So the unsymmetrical fault is nothing but single line to ground fault, line to line fault, and double line to ground fault. So compared to these three methods, the single line to ground fault is most severe, because in a power system almost greater than 70% of fault which are occurred because of single line to ground fault. So which is severe if it cause the other line to create the over voltage or the abnormal condition, that is root 3 times of the particular phase voltage. It will be increases enormous amount. So because in a single line to ground fault, there will be three symmetrical component. One is a positive sequence component, negative sequence component, as well as zero sequence component. So in zero sequence component, additionally one more element will be added. The one more impedance, one more reactance will be added. That is nothing but three types of neutral impedance. So if you are adding the neutral impedance in a total value, so the total impedance is getting high. So then, according to the impedance value, the current flow which is flowing to the ground is also gets changed. So while compared to the single line to line fault, the single line to ground fault is very severe in a power system. So but in line to line fault, which are occurred less than 15%, it is very rare. So during the wind season, so suppose if the the three lines, it is very sag. So with sag means during the wind season, so the two lines are getting overlapped. That is called as line to line fault. It is very rare, because if you are having any lag in a particular system, so the single line to line fault may occur. Suppose if you are structured with full tight winds, so there is no possibility to occur line to line fault. Occasionally, some of the trees or something will fall on the line to line, it may create fault. But it is also very rare. It is less than 15% only. So the single line to ground fault which is severe in the power system. Thank you.